Today is May 7th of 2025, and this is the Endo meeting, and we have topics. The so again, Kumavis has been implementing OCapN in Endo, and in order to faithfully implement OCapN on Endo, the pass style substrate needs to evolve the ability to express OCapN symbols, via selector, and symbol nea selector nea symbol, as it were, and also byte array, and that touches upon some work that has been long planned and coming to a head now in order to get OCapN. Oh, and then the third issue, of course, is the calling convention for objects versus functions, which is slightly different over OCapN. And then the other topic of interest, which is that OCapN may give us an opportunity to decouple decouple pipelining from listening to the intermediate copy data, which we can talk about as well. But that's topics 1 through 4, and then also Matthew and Mark and I have long planned to refactor Endo such that folks can enjoy the benefits of Pastyle and OCapN and CapTP in general, regardless of whether they're running on top of hardened JavaScript. And I kicked off some of that work last week on a hunch, and Matthew and I just had a great conversation. We'll recap here about what the next steps for that are. And I see right out the gate, here's Mark's hand. Go ahead.
Yeah, so just speaking on the Endo OCapN integration at the Pastyle level. So you hit on most of the things. I can give a status report on those, which is, first of all, we've got ByteArray implemented in Pastyle, mapping to immutable array buffers, well, mapping to our immutable array buffer shim, which we're now allowing ourselves to use as a shim because we believe immutable array buffers are now quite likely to land in the language. The remaining thing on immutable array buffers is that I see Leo has been continuing work on the PR for making the other shim of immutable array buffers available for Hermes, and doing it in such a way that which one you get depends on whether you're on Hermes. And that part of the configuration magic is something that's still mysterious to me. On the symbols,
before we go into implementation status, I would have preferred to get a overview of OCapN and what some of these things are, especially for symbols.
I can offer that. Mark, would you like to yield and then come back?
Sure.
All right. So the status of OCapN is that it's implemented in Guile as written, and that came ahead of a whole bunch of conversations where we've been basically for the last couple. All recorded recent history has been about driving the OCapN specification to an agreement between Agoric and Sprightly on what the data model is. The data model for OCapN gives slightly different names for the data model that we already have at Agoric for CapTP, but also additionally has symbols and byte arrays. And it also was the origin for the tagged type, but we're mostly aligned on that as well already.
I'm sorry, what's open about the tag type? I thought that was all settled.
The tagged is all settled, but the existence of tagged in Agoric's Pastyle and Endo's Pastyle was motivated by OCapN in the first place.
I'm not entirely convinced that it's all settled, but that's probably not relevant for this discussion.
I'm sorry, Richard. I just need to. I want to make sure I'm following the details. What is not settled about tagged?
The Agoric handling for tagged is that certain names are privileged and they're promoted into kinds. And I think that that is not necessarily true on the sprightly side. Such that, for instance, if you wanted to use a, a value for the tag that itself was a pass style, that's a problem on Agoric, but might not be on sprightly.
I think you might be confused. I mean, in the JavaScript representation, I think you might be confusing the value of the pass symbol. I'm sorry, the pass style symbol named property, which is which for tags is simply tagged, versus the tag name, which I don't think it creates. Oh, the kinds. Yes, I
Yes.
agree. Okay, I understand. Thank you.
I look
Yep.
forward to learning more about that someday.
Great. Not in this call.
Yeah.
Okay.
At least not today.
No, but I'm glad I know what the issue is. Good.
If there's a GitHub issue associated with it, if you could throw it in the chat, that'd be appreciated.
Yeah, for my benefit as well. I should know I should know about this. Yeah, anyhow, so essentially the data model for OCapN is that there are atoms and containers and errors are a special exotic thing that has not settled at all.
Yeah.
The atoms are all of the likely suspects, like big int and float 64 specifically. They have refrained from having a float 32, which is fantastic. And then they have strings, which are limited to Unicode valid strings. That is to say, no unpaired surrogates are allowed. Symbols are a different flavor of string in OCapN.
So to be clear, symbols are forgeable, but they're just strings that have
yes,
different type.
yes, yeah. There's no sensible. Well,
they're parallel strings.
they are parallel strings, exactly. And then the containers are what we call list, which corresponds to a JavaScript array, struct, which corresponds to narrowly string keys to heterogeneous value types. And then
string keys only, not symbol keys.
String keys only, yes.
Yeah.
And
then tagged. Tagged is the other
tagged. Yeah, tagged is the other container, which is just a value with a tag. And the constraints on the data model are about pass invariant equality. And the equality operator is one that is implementation specific. It's an OCapN equality. It doesn't necessarily correspond to any specific language provided equality operator. And then there are other pass invariants that are not yet codified in the specification, but definitely in the mix.
Let me just, since details matter, let me just mention a discrepancy between the equality operator we're using in Endo. That's a proxy for OCapN equality. The discrepancy between that and actual OCapN equality, it is -0. Other than -0, compare full giving 0 and OCapN pass invariant equality are the same thing, but we will need a more precise equality operator to distinguish the -0 from 0, unfortunately.
I see Eric's hand.
What is a parallel string?
That is to mean that the only difference between a symbol and a string for the semantics in OCapN is their type.
Oh, okay.
Yeah. The symbols are a broader term of art with different implications than that. So being very pedantic that they're just strings of another type is really going to be important when we dig into the equality semantics. Yeah.
Isn't there a presumption that at least, modeling the Lisp world that they're living in, that symbols are they're in turn strings. It's not actually required by the protocol, but that's sort of
it's not. The JavaScript symbols are in turn strings, or JavaScript registered symbols
Registered.
are in turn strings.
Mhm.
The OCapN symbols, there's nothing about OCapN that says whether or not they are interned. And the reason we're actually changing things on the Endo side is because we were using JavaScript registered strings
Right.
registered symbols to correspond to OCapN symbols. But that creates what for us is a fatal memory link. Fatal memory leak, specifically because of the interning. It's possible to do interning with garbage collection. Zero JavaScript implementations do that.
One does.
I would like to keep going down the route of explaining what the use cases, the uses of OCapN are before we go into implementation questions. Sorry. So I will ask then a clarifying question on, because this is exposing the data model, not exactly how symbols are used. So far, you've said that symbols cannot be used in containers at least in container keys. Can they can be used in container values? Where else are there uses in OCapN?
Symbols are used at for protocols above OCapN in a few small ways. The first of which is that there is the calling convention so OCapN does not distinguish method invocation from function application at the protocol level. These are both the delivery of a message.
So OCapN is not just data model; it's also invocation. It's also describing invocation protocol.
Right.
Yeah.
Because
there's a data model and a CapTP.
Yeah. If you don't have, if you don't have agreed invocation, then you don't have any interoperability.
Yeah. I mean, so far we've only described the data model. What's in the data. So how the data is used.
No, that's right.
And at this point, Agoric and Sprightly are beginning to discuss layers above the data model,
right.
And the core of it is that there is a deliver operator, which is how function application and method invocation get sent and pipelined as well.
And an operator is just, how is this represent?
The details are immaterial. It is a message that has an envelope around the argument values.
Mm-hmm.
Yeah, every operator corresponds to a message type, which is the top level parse.
Yeah. The top level message type.
Yeah.
Operator and
OCapN is a sequence of messages, each of which has an operator.
So I apologize for introducing confusion by raising the topic of interning. My point was the interning or not is irrelevant to the protocol.
Right.
Yeah.
And therefore you can get the effect simply by comparing the strings. In the Lisp world, symbols have this thing of slightly different syntax, but also the fact that you can compare them for equality trivially. But in fact, you can optimize string comparison by first checking if the pointers are the same. So I don't think that really matters. I'm just thinking that symbols play a much larger role in the Lisp ecosystem than they do in the JavaScript ecosystem because of this.
Mm-hmm.
Yes.
But I don't think it's material to the protocol.
Yeah, it is, but it is material to the confusion that has led us to this place. There's one premise that proves false on inspection is that if you use a registered symbol to represent an OCapN symbol in one language, it is sensible to do the same in another, and that is broken on the face, because if we were to use registered symbols in JavaScript in an implementation that is intended to be used across multiple VMs, then then you don't really have then you would have a registry stuffing attack vulnerability on one engine and not on another.
Okay, we're getting back into the weeds of
Yeah, I
this.
apologize
Would
for
like
going
to-
back there.
Drawing back.
Backing out a little bit for Chip, the presence of symbols in the data model at all at this point is essentially a concession to the developers that prefer to write in Lisp.
Right. So
that was sort of by implication what I meant, but yes, okay, thank you.
So in practice, what this means is that we will be arranging for high order OCapN protocols, basically at the EXO layer. There will be agreements at the EXO definition layer for protocols that will be implemented both by Sprightly and Agoric for interoperability across that. This isn't the case yet, but for example, there will probably be a PubSub protocol that is expected to help a Sprightly implementation interact with a JavaScript implementation. So let's talk a little bit more of where symbols actually would show up. By convention, Sprightly implements method invocation as the target, which is what they call an EXO, or what they call an actor, but we've agreed that target is the common ground. The OCapN name for what Sprightly calls an actor and what we call an EXO.
Actually, what we call a remotable.
A remotable.
So that's basically the receiver of a message.
Yes. Yeah, exactly. The calling convention on the wire. Well, pardon. On the scheme side, all such objects are implemented as functions that take a symbol by convention as their first argument, and the symbol is the referenced behavior that they want, the method invocation, the method name. On the JavaScript side, we have objects, and in the JavaScript reification, the method names are strings, but OCapN creates a bottleneck. And in that bottleneck, it's basically that in the reification in any particular language, you can either have a string or a symbol. On the wire, it's going to be an OCapN symbol in that position, right? So on the JavaScript side, we do not have to acknowledge the existence of symbols as method names because we can parse them out as strings without reifying them at all.
With one exception.
Go ahead.
But we also support functions. You can have an EXO function, right? Yeah. And if you have an EXO function and you receive a message, you will be able to, if you had a JavaScript eventual send with a method name to another JavaScript engine that implemented the receiver as a function, the first argument would be reified as whatever our representation of a symbol is.
Right.
That
was the exception I had in mind.
Yeah.
So it is expected then if you have a target of an eventual send message being a function, that they must accept an undefined first argument if they don't care about a name?
Not undefined, an arbitrary first argument.
I don't understand what the arbitrary or undefined is. Using a function, invoking a function as if it were an object, reifies the method name as the first argument to the function as a symbol of the same name.
All right. Let me put it as an example. I want to be able to declare an EXO function.
Okay. There's two purposes that you might have in mind. One is that you just want to use it as a function. You're not trying to use it to reflect on an object protocol. So if you're just trying to use it as a function, then there's nothing special about the first argument.
I'm trying to use it as a function. Let's say we have a model where yeah, I want to be able to provide a callback of some kind. My exo is stored as my exo function is stored as a callback. What is the invocation model for that?
If you're just calling it as a function, then there's nothing special. There's nothing special about the first argument. You just use it as a function.
So if you're using eventual send, it's E of the receiver and then just call with no method name.
Right, E of the receiver. Yeah, but how does that show itself on the protocol?
That shows itself on the protocol with no method name, just as a function invocation. The protocol is described.
When you say no method name, that means a missing first argument or
No.
a first
No.
argument with a something else.
Well,
The first argument is the first argument you sent. It's not something special in the protocol. The
This is
basically
going to be a problem. This is going to be a problem.
The ontology is that at the lower level of abstraction, there is only function definition and function call. So everything, all OCapN invocations are always function calls. And if you're just using it as a function and you're defining, and the thing being called is defined as a function, then there's nothing special about any of the argument positions.
So this is definitely going to be a problem for eventual send in Endo, because eventual send currently is implemented as there's always a method name effectively, and the method name is undefined for function invocations.
Yes, which is something we'll have to compensate for with developments on eventual send on our side.
Yeah,
and the way it currently works in my implementation is that when you create an object as opposed to creating a function, with like far or something like that. I haven't worked with exo in this implementation yet. You just pull off the first argument before applying, use that as the method name before applying the arguments. You get to interpret this list of arguments.
Yeah, the problem with eventual send itself is a genuine problem that we need to fix, and it's going to be hard to fix. And we were aware of this when we negotiated this agreement with Sprightly during the OCapN meetings. I initially resisted and then finally agreed. But yeah, this is the thing that needs to give in order to bring the world back together is eventual send. And it's a little unclear how much layering pain that's going to create, because in order to fix eventual send, you need concepts that are right now only introduced by the pass style level, which is several levels of abstraction up from eventual send. So this is going to be hard, but the model that I was initially advocating, that we eventually agreed to ditch, is much more object-centric rather than function-centric, where everything is an invocation with a method name, but a function invocation is basically an invocation with a method name of undefined. And that's much more E-like as well. It's JavaScript-like, not that JavaScript itself actually does that, but JavaScript, an object can have both a call behavior and properties, which are functions that are acting as methods. But in any case, we negotiated this. It was hard, and we gave up. We conceded to Sprightly. So anything that will interface with remote invocation is going to have this function-based reflection on the object protocol, as I described, and that's incompatible with the current behavior of eventual send.
It might be that we have to introduce something like an call to get around this.
It strikes me that you basically either everything is a method invocation and we treat functions as a special case with some under the hood voodoo, or everything is a function invocation and we
Yeah.
treat method invocations as a special case with some under the hood voodoo.
That's right.
Either model is fine, but we have to agree which model the wire protocol is using,
Yeah, and I prefer the object-centric view. It's what I did in E.
as do I.
But we conceded and agreed to the function-centric view.
And we wouldn't have, I think, without the observation that we don't have to reify the symbols if the receiver is object-like.
Right.
All right. So the other, and that answers half of the question, Matthew. Like, what are we actually using symbols for in practice? That's on the wire, by convention, the method name.
I have one more question about symbol usages. Is there ever a need to? So, are symbols?
Our expectation is that they would only be reified in data elsewhere as enums or protocols, and probably only in protocols.
Sorry, I'm sorry, what do you mean by enums?
String unions, but symbol unions.
I'm just confused about, I mean, when Sprightly uses, passes a symbol as just a first-class value, either in an argument or within data within an argument, then that stays a symbol in the protocol. And the fact that we can have some representation for symbol means that we have interoperability on that. Where what we initially fantasized we might be able to get them to agree is that OCapN only does strings, not symbols, because but we as part of this concession on reflection, once we conceded the reflection issue of functions versus objects, then conceding just symbols as first-class values followed naturally.
They insisted, Sprightly, on being able to use symbols in places that are not method invocation.
So my question is, since symbols show up in the data model in different places and values and so on, is there an expectation that code interacting with them might need to use symbols in data structures and more specifically as keys in anything?
So it depends what you mean by keys. The only at the purpose of JavaScript symbols is identity, meaning essentially same pointer, and structs, i.e. records. You can use them as property names, and then there's also JavaScript maps in which you can use, and even weak maps in which you can use symbols as keys. We don't, at the pass style level, what's exposed is not JavaScript maps. It's
right at the pass style level, but I'm asking about any code that is directly interacting with where symbols might show up.
So the answer is at the JavaScript level, the thing that we're going to bind OCapN symbols to do not have a stable identity. They're actually created fresh on every unserialized.
Well, that is one implementation choice.
So in the data model,
it's the only implementation choice possible without creating a fatal memory leak.
That it is still one implementation choice. I'm trying to understand what the constraints on the different constraints might be. Including...
So this, I think I do have a good understanding of, like, in the data model, the record object, whatever type, it supports only strings as keys, but the to be determined what Agoric and Sprightly do about a higher order, like a copy map tagged type. I expect that will support symbols in key position,
Yeah. And
just like it'll support strings or arbitrary objects or whatever.
right, and that's already that's already defined as the representation of copy maps. And that's one of the reasons why I go back and forth about whether the OCapN name for the thing that we're talking about should be symbol or selector. Is that I think the protocol representation of symbol should be the thing used for this category of stuff. And wire, so the wire representation doesn't change. It's just what we're changing is what the JavaScript representation is that corresponds to that OCapN type.
So let's talk a little bit about, are we ready to talk? I answered the question, I think, already of whether symbols are used in places other than method names. They are used to, if you were going to say that this method can have 3 different behaviors and you have to specify that with one of these arguments, well, you could use a number, you could use a string, but if we're talking to sprightly people, they're going to use symbols there.
I'm sorry, I did not follow that.
If we are going to implement a protocol above OCapN, and that protocol would be is going to be a contract that is shared by Sprightly and Endo,
Yeah.
like PubSub, for example, something primitive and useful in the extreme. If one of those behaviors needed to have behavior variants in JavaScript, we would usually use a discriminated union of strings. Sprightly would definitely use a union of symbols.
Okay. This is basically just the use case for enums.
Yes.
We understand that there are use cases for enums, and we're kind of stuck that the JavaScript enums will be typically strings, whereas the sprightly enums will be typically symbols.
And the C enums would typically be numbers.
Okay.
Go enums would typically be numbers. Those are all on the table.
Okay.
And that is a place where a symbol might show up.
Okay.
All right. So with that aside, I think we can start talking about the implementation options.
Okay. So the implementation. So first of all,
do you agree, Matthew, that it's time to talk about implementation?
Yes, it is time to talk about that.
Okay.
Okay. So let me start by giving a status update. There are 3 relevant PRs that I've authored on this, 2 of which are in review, and the 3rd is going to be redone with so the 2 that are already in review. One is to just abstract out the creation of the JavaScript values that correspond to OCapN symbols. So the symbol module inside the pass style of package already exports functions named passable symbol for name and name for passable symbol. There were also a lot of test cases that wanted a counterexample, a symbol which was a counterexample to a passable symbol. So I added in this PR the new exported function unpassable symbol for name, which just is just a local symbol value of some sort that is not recognized as passable by pass style of. So what I've done is, without changing the representation of symbols, I've simply pushed through the abstraction of symbol creation so that everywhere else in Endo, not in Agoric SDK, I've got other PRs in progress there, none of which are in review, but at the Endo level, I just push through the abstraction of all symbol creation, which is creating where I'm creating symbols for the purpose of passability or for the purpose of non-passability for test cases, I'm now always using those abstracted functions to create the symbols rather than manually using symbol open paren or symbol.for open paren.
So that's a refactor PR that's pushing the implementation details out.
Yeah,
that's right. Well, it's hiding the implementation details. Depending on how you want to describe it, it's saying that and also symbol.keyFor, you use name for passable symbol instead if you're using it with the expectation that you're applying it to a passable symbol.
the
And I
practice.
suppose you have a symbol.equal somewhere.
Yes, that's right, I do. So the result is that PR is a pure refactor. It is in review. I don't think I've gotten if I've gotten any review comments on it, it'll be from somebody here. So let me know. But since it's a pure refactor, it has zero compatibility issues because we can integrate. It should not create any incompatibility with Agoric SDK, which is still using the old way of creating symbols. And after the next Agoric SDK Endo sync, then we can transition Agoric SDK to use the refactored abstracted names again with no compatibility problems. Okay, so that's one PR. The next PR.
I suppose the next PRs are closer to implementation choice for this.
Yes.
Can we talk about the field of possibility for implementations first?
Yeah. Yes. I think that there are three sensible options, one of which I reject, which I think that you're hoping is still on the table, but we'll talk through that. Let's talk about them. The first is the obvious symbol for. A registered symbol is one possible representation. And we'll go through the pros and cons later. A gensim, this symbol constructor for name for description.
A unique symbol, yeah. Okay. Let's use the JavaScript spec.
I don't even know. Is it unique symbol?
Yeah.
Is unique symbol the accepted term in the spec?
Mm-hmm.
Okay. And then the third option, string is not an option because it has to round trip and be distinguishable. An object with a symbol key pass style is also an option, provided that there is another property of that object that is the string representation of the symbol.
Right. Okay. That would be the toString tag.
Yeah. So those are the three under consideration.
For the first two options, I would like to add an orthogonality to that, which is the ability of somewhat differentiating these from symbols that the user might have created on their own, possibly mistakenly. And that's the possibility of namespacing the description.
Mm-hmm. Do that
somehow.
Yeah.
It's not bulletproof, but it is.
We could, for example, have an OCapN colon prefix to make it entire exactly. or pass style if in the generality. The hope is that this would be a decision that would continue to make sense if eventual send and pass style were orthogonal to even OCapN.
I had not considered unique symbols with an OCapN colon prefix.
Neither had I.
That right there makes the unique symbol possibility much less distasteful.
Still, okay. So there remain other orthogonal pros and cons. All right. Mm-hmm. So for behind door number one, registered symbols. The disadvantage of registered symbols is that if you are writing an implementation in JavaScript that needs to run on V8 in particular,
or XS,
then you are
No, it's because excess will leak no matter what.
What?
Excess leaks. My understanding is that excess leaks unique symbols the same way as it leaks registered symbols. So
okay.
Oh my God.
So only in the third case would it not. So all right. So that's a factor. So
Yeah.
I mean, to be clear, that's until the key collection stuff is in. But then I don't know for unique symbols what excess does when key collection works.
I see.
And if
I
there's
see.
and if for registered symbols, it might be able to collect them similarly as unique symbols. So
Haven't they
I'm not sure.
implemented key collection a long time
Key
ago?
collection is implemented. We need to check with Mutable, but I would
Okay.
not
I'm
just
pretty
go ahead and say like
Okay.
they're not collectible either.
All
Okay.
right.
Here's the reason why I believe they did collect it. They did make them collectible as part of the same change, which is one of the things that convinced them to do the change we were asking for string keys of records.
Right.
One of the reasons that convinced them is JavaScript requires unique symbols to be able to be used as weak map keys.
No, and they implemented that. Yes, correct. But I am not convinced that when they did that, they also did not implement registered symbol collection.
Okay, we should
that would align. They were not registered symbols and unique symbols were not particularly different in excess. And
Really?
they might have been able to implement collection the same way they implement the key collection for registered symbols.
All right.
Okay, so interesting.
Okay.
I don't know. We need to check.
All right. So for registered symbols, we know of at least one engine where we would like it to work, where a message from an attacker could stuff your key registry, and that there would be no way to prevent it except refusing to connect. But the advantage.
That's not entirely true. You're still parsing. You still need to parse the message somewhere. So you can have other protections saying like, hey, you have a quota of n symbols that you could send me, and at some point I'm considering you.
Right. Yeah, and then you would have to do IP banning or something like that to prevent them from attempting another connection and then stuffing your registry with another batch of registered symbols. It's hard. I think that would be existential for the protocol.
The problem is that I don't know what the other semantics are regarding object references and C-lists sizes and so on. So in that sense, you can impose obligations usually in different ways. If you're introducing objects, you are introducing obligations to be able to reference those objects.
Yes. Yeah.
Yeah.
All of those are collectible after the connection closes.
The objects are collectible, period.
They're collectible as
we're not going to intern these objects. They're just collectible.
The peer is in a position to compel you to retain them until you disconnect. They can cause that. Yeah.
No, they can't. They can't. How can the peer compel you to do that? They can keep sending it to you, in which case you create it again and then you drop it.
Yeah,
I agree with Markham, but I mean, the implementation has to actually do that.
Well, that just sort of, with the object representation, that just the path of least resistance follows that you get good GC behavior.
Yeah, you are in a position to defend yourself as long as there isn't a registry. Okay.
Yeah, and we don't do a registry because that's the whole point, is we're trying to avoid a registry.
Yeah. They can compel you to retain answers, an arbitrary number of answers until you disconnect, but not data.
That sounds right.
What? Wait, sorry. Answers.
The references to targets. They
Oh,
can
by
grow
not
your
by
seeds.
not by not doing their part of the distributed acyclic garbage collection protocol.
Yes.
Yeah.
Okay, so with regard to leaks that are a result of the counterparty misbehaving with regard to the GC protocol, that's another level of attack. And yes, we're vulnerable to that level of attack while the connection is open.
Yeah, and I think to Matthew's point, you could do a limited scope registry. You could do a per connection limited scope registry.
Why would you do a registry at all? I mean, the whole point is we're trying to avoid the registry.
Okay, so the pro of using a registered symbol is that you get trivial identity equivalence, which is something that people might expect.
Yes.
You wouldn't be able to guarantee it for when they're exporting symbols, because they could create two symbols with the same name and it's not enforced. Like unless it needs to be in that custom registry to be patterned.
The OCapN connection would be obligated to do the interning.
It would not.
We couldn't use
it could not do the interning on a per connection basis. It would have to do the interning collectively for all connections.
That's true. Yeah. Well, okay, so that brings us to category 2, which is unique symbols. And in unique symbols, we could recover. So there's another case. We can use unique symbols with OCapN scoped interning tables, or without, and it's a difference of whether you're going to preserve simple identity equivalents of symbols. Right. And I don't think that particular case requires much introduction, but it is an option. It has, the pro of it is that symbols in JavaScript correspond to symbols of some kind across OCapN, and it's just symbol, which is simple to understand, even if it's not motivated. The third category is an object that contains the name of the symbol and its pass style is symbol. And Mark discovered a very strange pro to this approach, and that is that Ava's deep equal operator would be much more close to converging with pass invariant equality.
Yeah, and in fact we use t.deepEqual in our test code all over the place. And one of the third PR that I mentioned that I need to do over actually went through and fixed every deep equal that was shown to be a problem by CI. So it was all just empirically driven. It did not try to replace all t.deepEqual, and it's just a mess. So I would really so there's of the 4 solutions that we've talked about, the only one of them raises this deep equal problem, and that's the solution in that third PR that I need to redo, which is that we're using unique symbols, but we're creating the unique symbols fresh on every unserialization, and there's no registry. If you're using unique symbols with a registry so that you're preserving identity, then no problem with t.deepEqual. If you're using registered symbols, we've got the fatal leak that we've talked about, but still there's no problem with deepEqual. If you're using the object representation, then again, there's no problem with deepEqual. So deepEqual is only a problem for non-identity preserving unique symbols that are pass equivalent based on their description strings, not their identity.
The custom structure comes with a registry as well?
No. Well, actually, that's a choice. But I'm strongly advocating that we I'm strongly advocating that if we go with the object, which is also overall my preference at this point, we could still consider a registry-based implementation of the object. But at that point, what's special about this object versus any other object, any other path by copy object, is I don't see any motivation for adding a registry table for the object representation.
Well, yeah, the only thing is how much people might be expecting. How much people might be expecting to have a
Deep equivalence.
to be able to a natural language equality for these values, and like if they should be able to use them in maps, like native maps and stuff like that.
Yeah,
That's my main concern with something that that has a unique identity. Like we're saying this is a value which you're expected to compare that is comparable for the semantics of OCapN, but that you cannot use the language comparators for.
Yeah, but you can use map stores and copy maps.
Right, but you cannot use like that. I mean, we have another value that's like that, which is promises. Promises were, but the promises have never been. We've never told you that you can compare them at the.
That's right. That's right.
Ever. So
yeah, promises and errors are both exempt from from any notion of pass invariant equality.
Right. And so now we're basically introducing a value that you're saying that for passing, we're saying it's comparable, but now the language comparators doesn't compare them.
That's right.
And it feels very uneasy to me.
So I see Aaron's hand.
Oh yeah, just why are promises not subject to the pass invariance equality, or not subject to what were you saying?
It's
Promises, we don't guarantee identity comparison for promises.
Why is that?
I think fundamentally is that they can be moved around. You don't know when you get a promise from Alice whether or not it's the same promise that you got from Bob. So therefore, you don't even know when you get them both from Alice.
Yeah, there's this abstract level at which there is a pass invariant, which is if two promises are abstractly considered to be the same promise. I'm sorry, if passing promise P is received as promise Q, then if promise P eventually fulfills to a passable value, then promise Q must also eventually fulfill to the same value. But notice that is not testable.
Sorry, I would like to backtrack on the statement I just made. That is not true. There is other things. All the copy data actually is something that is passable and equal at the CapTP layer, but that is not comparable using JavaScript built-in comparators. All these are objects, so in that sense, I might feel better if we're using an object with a unique identity to capture selectors.
I think we're on the same page in that regard. That object appears to be the least surprising, and the least surprising except for naming it symbol as opposed to selector. But I really would prefer to name it symbol, since in OCapN and scheme it corresponds to a symbol.
Yeah.
I'm still torn on the symbol versus selector thing. The problem is that the pass style of is going to classify it as a symbol.
Yeah, that's just confusing. It would be nice to have something that is not conflicting too obviously with JavaScript, but especially if it's going to be so different.
My opinion on this is that in practice, these are going to be rarely seen, and that I don't mind there being an edge case.
So to summarize, my position is like I am more comfortable if it is an object that has a certain structure and that has a pass style, whatever symbol selector that that requires explicit comparators, because we already have copy data that is represented as objects and that requires explicit comparators.
But deep equal by dint of coincidence will handle it just fine.
Yeah, that's the constraint that I now care about, and I would not have ever thought of the constraint if I hadn't empirically run into it and trying to do that PR.
Oh, also, please don't introduce weak registries.
Yeah, weak
But I don't
registry.
care if you do, but please don't.
Yeah.
Okay.
Specifically for the symbols selectors?
Yeah, if we were doing it with unique symbols, to do that with both identity preservation and garbage collection, there's no choice but a weak registry. And yeah, my sense is the same as Matthew's. It would work, it's logically correct, but I would like to avoid it.
Yeah, same.
What's the dislike?
I'm on the hunt to get rid of any weak ref and finalization registry at this point. I don't. It's just it's implementation dependent. I'd like to get out of implementation dependent behavior.
Yeah,
Okay.
it makes garbage collection decision. The weak ref and finalization registry themselves make garbage collection decisions observable. And we would like to get to the point where when we have, let's say on the blockchain, replicated engines, that they don't have to agree on micro garbage collection decisions. Right now, they still do, but it would be nice to be able to encapsulate that. Now, that's not a strong argument because the weak registry would not expose the observability of garbage collection. It would still encapsulate the observability while making use of it.
Does that mean that we shouldn't use unique symbols with the registry or not because their GC is observable?
They're not observable.
Yeah,
They are observable.
They're-
Oh, sorry. Yeah, unique symbols. No, which one is? Yeah, unique symbols are observable.
If you use weak ref or finalization registry, my goal is to just not have anywhere in our code where we actually observe GC and then to not give those powers to user code.
Right.
Yeah, but that's an important part of the export table, or it's an important part of CapTP is being able to do GC.
Yeah.
They are.
OCapN doesn't have to be entrained within any. OCapN is an Endo thing that doesn't float into the.
So there's different GC that we're talking about here. There is a GC that is linked to your implementations GC, and then there's a GC of your distributed objects. Those don't have to be related.
Can they not be entangled?
Yeah, let me explain that Matthew has the thing that makes Matthew's position coherent is the anticipated implementation change that Matthew has in mind. And I don't know the degree to which we want to turn all Endo use into the implementation that Matthew has in mind. I'm open to it, but
I don't know. I don't think that we can. I think that the carve out that Matthew is making is very specifically useful for simplifying Agoric's chain, but isn't the right trade-off for every use of Endo.
I
fundamentally
consider.
don't follow.
So I'm not convinced either way, and I think it's a good thing to discuss. But let me explain first what implementation change for VATs Matthew has in mind that makes the rest of this coherent, which is that that there's no snapshots other than snapshots of zygotes or replay of zygotes. But aside from zygotes, there's no snapshots. All durable state is only saved via, basically the only state that lasts between one crank and the next is the durable state that goes to the KV store. And that at the end of every crank, you shut down the virtual machine, and then you start serving the next crank with a fresh instance of the virtual machine with the same durable state and starting from the same zygote.
And in that world, there is just no, you cannot store anything ephemerally in the engine's heap. And as such, you don't care about the engine GC.
So essentially, you're getting rid of the when we had this reference tripod, you're getting rid of the memory leg.
Correct. You don't have one. I mean, you lose it. You automatically lose it at the end of the delivery. So
right. So the non-determinism problem had to do with when the engine GC let go of an object and that object was exported remotely.
Right.
Then that became a visible event. Now you're going to say, no, the only things that get exported are things which are held durably.
Correct.
And therefore, durable stuff can get GC'd, but it's not going to be GC'd by the engine. It's going to be GC'd by you.
Well, it's going to be GC'd by the durable, by
that machinery as opposed to by the JavaScript machinery.
It's a GC of the durable states, which is implemented. It's our own GC basically. We don't rely on the engine GC.
Right. And so you can control when and under what circumstances a GC event happens.
Okay.
And thereby make it deterministic. Is that the idea?
Yeah. Well, I mean, right. We implement it's deterministic. It's dependent on. So I don't know in the OCapN world how that works. I don't know what the OCapN GC events are. Most likely to implement distributed GC in OCapN, you will have to have GC events that each local VAT or agent, or I don't know how they're named in OCapN, helps trace their dependency
Their
list. So basically,
yes,
yeah.
But that's a question of how is GC exposed at the protocol layer so that you can implement distributed GC.
Okay.
Yeah, there are explicit deliveries you can send to release entries in C lists.
That is not sufficient to do cyclic garbage collection, distributed garbage collection.
It is known that it is not sufficient. It is that OCapN it is a limit to the usefulness of OCapN intrinsically, that you might be talking to a peer that just does not send any releases, and it's meant, and the intention is that those are peers that you should at the next layer up choose to just stop talking to.
Right. But even then, you're going to require more. You're going to require a different event than just increments and decrements, obviously. But yeah, so that I don't know where OCapN is at in standardizing and talking about that, but we know we're going to need to do it for us in swing sets. We have an opportunity, however, to not have to do it with that protocol because we can take a holistic view of like, hey, let's look at all the durable states all together synchronously and be done with it. So anyway,
Yeah.
One of the things that my recollection is we were never effectively garbage collecting, other than ref counting, which was vulnerable to internal cycles between durable references. Durable reference GC was not done because it was expensive and we couldn't figure out a good way to do it. Have you figured out a good way to do it? Because that'd be cool if you did.
no, I mean, well, it's a GC, so if you're only doing it on durable storage, you can just go through your roots and trace everything and figure out
Right, but
what's
your mark and sweep of stuff on disk is expensive.
yes.
Okay,
But
so
it
you're
doesn't
just
have
prepared to pay the cost, and that's just how it is.
it also doesn't have to be happening.
Yeah, you don't have to do it
doesn't
every.
have to block. It doesn't have to. You can do it in parallel. It doesn't have to block the rest of the
Right,
execution.
right, but you can do it, yeah, and you can do it once a day or
Yeah,
whatever.
there's one critical thing if you're going to do it in parallel, which is you need monotonicity. You need it to be the case that if something seemed to be garbage by your garbage collector at a previous point in time, then you know for sure that it remains garbage. And
Right.
the reason, and that's generally that's true at the level of durable state and durable references. The reason I'm bringing this up, though, the reason I'm mentioning it, is that you've got to be very careful specifically about weak references. Your garbage collector, your pre-garbage collector, your predictive garbage collector has to treat weak references as strong if they exist at all in the thing that the garbage collector.
They don't. We don't have weak references
in the durable graph. Yeah.
In the durable graph, we don't have weak references. We actually don't have weak references anywhere. So once garbage is found, it remains garbage. There is no way to reach it.
Right.
And that's something that can happen entirely out of process.
Yep. Dean did that in a contract between Agorix, the Agorix company from the 90s, a contract with, I think it was Objectivity, with some object-oriented database, where we did this predictive garbage collector, and it was really cool.
All right, we're at 15 over. This has been one for the record.
Oh, sorry. I do want to mention the second PR because it's still not taking a stance on what the representation is. It's not till the third PR that you have to decide on the representation. This entire agreement on object versus function with OCapN, with Sprightly, means that for normal objects, there can only be one namespace, one string named namespace, which on the Sprightly side, for objects that talk on OCapN, we're expecting that to be symbols, and on our side, we're expecting it to be strings. What that means is remotables must no longer support symbol named methods. And I've gone through that on the Endo side and fixed all cases. Well, first of all, enforced that and fixed all cases. And I think what I'm going to need to do on the Agoric SDK side is first fix all uses. I'll need to split the Endo PR into two PRs, one which retains the fixing of all uses, and then the other of which does the enforcement. And the reason is not we always want Agoric SDK to be compatible with a prior and a next Endo to ease the integration between the two.
This is going to be an upgrade nightmare. I mean, I'm assuming the biggest problem is going to be the symbol iterator or async iterator there.
Those were 90% of what I encountered. I've already tried tried this in a draft PR for Agoric SDK. I think it's not going to be too bad.
No, it's going to be terrible because you're going to have to do that in multiple releases steps anyway. Because at the very least, you need to first introduce the fallback, the alternative that is string names. Make sure all your producers are able upgrade to using that. And then in the subsequent upgrade, make sure all your consumers switch to using the string name version.
You're right. There'll be 3 phases for Agoric SDK, but there only needs to be 2 releases of Endo in order to play with.
But there needs to be 2 waves of that upgrades.
Is the
Yeah.
For VATs that actually can upgrade, which is
also for VATs that are actually either receiving or sending these symbol named method names, which are going to be very rare.
not that rare.
I am only comfortable with doing a migration if symbol names on the wire is 0.
Well, yeah,
I'm comfortable with fixing all of the tests that exercise symbol names. I don't think that's a problem. But if there's any contract at all that's
There is
symbol
plenty. All the notifiers.
Notifiers are actually transiting the async iterator symbol?
I think so.
I thought that they were not.
I thought, yeah, my impression was that they were not, but I'm not sure. Richard, you probably would know much better than any of us.
Yeah, but even I'd have to look.
Yeah, okay. So it's a question of whether there are any exos with async iterator symbol async iterator for a method name.
Well, so what
notifier is all based off of like clients that just
do they transit on the wire ever?
I don't think
they definitely could. I mean,
they could.
All that code was designed with that in mind, but it may or may not be in active use.
Yeah, the other thing that I did in the experimental PR for Agoric SDK is that one uses an environment variable to determine whether or not we grandfather a special case specifically for async iterator alone.
A legacy exception, yeah.
Yeah.
So the reason why we're not accepting symbol named methods is what?
It's because we need a mutual exclusion in order to get one type on the wire.
Right. When Sprightly invokes an object, what they consider to be an object, they're going to be invoking it as a function with the first argument being a symbol.
Mm-hmm.
We're
I
going
think
to
as the implementer of that far object, you get to interpret the arguments.
Yeah,
like
but given that the only thing that's different from one of those to the next is the name of the symbol, how would we interpret it to determine whether we turn it into a string or whether we turn it into a symbol on reception as an object?
I can say that I am perfectly comfortable, if necessary, making an exception specifically for async iterator and only async iterator, so that it flips to async iterator must be a symbol if present and must be a string if otherwise. That doesn't break the bijection.
Async iterator as a name?
Basically, if async iterator as it appears on the wire today over CapTP and live slots and whatnot, we're treated as the one and only name on the wire and whatnot that gets interpreted as a symbol if it gets to an exo.
On the wire between VATs, it's encoded as what is currently a symbol in Pastile.
Yeah, and it's a symbol with it's some number of prefixes to distinguish it as a well-known.
Yeah.
Yeah, I'm fine with making a pinhole for that.
Right, it's double at.
Yeah.
So it'll be a pinhole for double at, and I think it's fair to say that this name is reserved so that if if a remotable has a string named method whose name is at async iterator, and it has a symbol named method with the well-known symbol async iterator, we can even just reject that when we determine whether something is a remotable.
Yeah. Yes, I'm fine with that pinhole. That would greatly simplify the migration story. Okay.
Are we done for the record?
I'm sorry?
Are we done for the record?
We can be. Let me wrap it up with a summary of our findings. It seems like the read of the room is that on the JavaScript and Endo side that we are collectively most comfortable with representing OCapN symbols as an object with pastyle symbol and two string tag of the actual name of the symbol, and then we'll run with that. We're also comfortable with making a pinhole for the well-known async iterator, such that that will be captured as an EXO with that symbol name instead of the string name, and only, yeah, for the bijection. And then apart from that, we've got a bunch of topics for next time. See y'all soon. Sound good? All right.
Matthew, did you want us to stay connected after we go off the record?
Yes.